Hello, so this video is just a review on some concepts from Algebra 2. We're on our 1.7 notes, transformations of functions. So in today's lesson, we're going to be transforming those parent functions that you learned about last week. So you learned about the constant and linear. We're actually not going to touch those because that's stuff from Algebra 1. But we also have our parabola, the quadratic, absolute value, the square root function, and the cubic function. We're not really going to do too much with the reciprocal function today either. So today you're just reviewing what a rigid transformation is and applying those to those functions. So rigid transformation is simply taking a function and moving it up and down, left and right. You're not changing the shape of the graph. You're not making it wider or skinnier. You're just simply sliding it up and down and left and right. And these are called rigid transformations. So a vertical shift, that's moving it up and down, happens when you are taking the function and you're adding a number after that parent function has been applied. And that'll make sense when we look at these examples. So if you have your function and you're adding a number to it, that means we are going up that many units. Whereas if we have a function and we're subtracting a number from that function, we're going to be shifting that graph down that many units. Now a horizontal shift, that is moving our graph left and right. Now, this happens if you are adding or subtracting a number from the x value itself, which should make sense because if you take a look on like your x and your y axis, your x-axis is the horizontal one. So if you're adding or subtracting something from x, you're moving left and right. But from here, if you're adding to x, you're actually going to the left that many units. Whereas if you're subtracting from x, you're moving right that many units. So if you want to write that those are the opposite signs of what you would think, you could go ahead and do that. So to graph a shift, you're going to graph the anchor points, and we'll go over those again, and then apply the horizontal and vertical shift to each one. So we'll talk more about anchor points tomorrow, but today we're just going to sketch our parent function and then move the whole thing. So let's talk about the shifts here. So in A through D, we're going to identify the shifts. So this might make more sense here. So taking a look, they all have a parent function. I'll abbreviate parent function as PF of y equals x squared. So in letter A, you have the function itself, that parent function, and you're adding 1 to it. That is just like here. You have the function and you're adding the number 1 to it. That means we are moving up 1 unit. Whereas in letter B, we have our function and we're subtracting a number from it. That means we're moving down that many units. Now the difference is when you look at letter C, we're adding directly to that x value. So in letter B, you squared it and then subtracted 4. Here you're adding 4 to x and then squaring it. So since it's happening directly to the x value before anything else, that's moving it left and right. So this is going left 4. And then in letter D, notice here, our first thing I see is this minus 2. Since it's being subtracted directly to the x value, that's moving it left and right. So this is going right 2 units. And then this minus 3 here, that's happening after the square, so that is going down 3 units. So now we're going to sketch these using our knowledge. You can draw your axes here if you wish. I'm going to draw the first one down a little further just because I know what that one looks like, and then the other ones can be normal. If you have a different set of colors, that might be helpful. If not, it's not the end of the world. So our first one here, we have x squared plus 2. So our parent function here, that is going to be our quadratic, just x squared. Now, anything besides that parent function, if we were adding, subtracting, multiplying, anything to it, that's going to be a shift. So we have our x squared, we're adding 2 to it. That plus 2 is a shift, and it is moving up 2. So to help you draw this, I'm going to first sketch my parent function. So I'm going to put my parent function in black, and then we're going to shift all those points up 2. So what does x squared look like? Well, we know when you plug in 0, 0 squared is 0, so we have the point 0, 0. When you plug in 1, 1 squared is 1. And when you plug in 2, 2 squared is 4, so we have the point 1, 2, and then 4. And we also know that it is reflected. So this is our parent function here. Now, to graph x squared plus 2, we're just going to take those points that we plotted and move them up 2 units. So starting at 0, 0, we're now moving that up 2 units to 0, 2. At 1, 1, we move it up 2 units. We had 2, 4, so then we move that up 2 units as well. And then the other ones will follow suit. So that is the quadratic moved up 2 units, or also known as x squared plus 2. So looking at our next one, we have the absolute value of x minus 1. So the parent function here is the absolute value of x. So the shift is anything besides that absolute value of x, and that's this minus 1 here. Because it's happening directly to the x value, that means we're going left and right. The subtracting from it means that we are moving right 1 unit. So again, I'm going to draw my parent function in black. You should know what the absolute value of x looks like. We've got 0, 0, 1, 1, and 2, 2. And that gets reflected over. You will not have to draw the parent function for every single one. Just doing that for your notes so you can get the hang of it. And what we want to do is we want to take these points and shift them to the right 1 unit. So from 0, 0, we're moving that. Our new vertex here is 1, 0. At 1, 1, we move that to the right as well. And then as well, negative 1, 1 comes over to 0, 1. Notice the shape has not changed. All we've done is slide our graph to the right by 1 unit. And our last example here, we have the square root of x minus 3. So our parent function is just the square root of x. This minus 3, that is a shift. Now it's happening after we take the square root of it. So since it's happening after the square root, that means it is going down 3 units. If you wanted to move it right, if it looked like that, this would be right 3. So because it's happening after the square root, or after the square root of x, that means it's going down 3 units. So let's plot some nice points for the square root of x. Some good points to know. If you plug in 0, the square root of 0 is 0. If you plug in 1, the square root of 1 is 1. And just to keep nice whole numbers, another perfect square would be 4. So we could plug 4 in, and the square root of 4 is 2. So we are up here. So that's our parent function. Now we're going to be taking each of those points and moving them down 3 units. So instead of 0, 0, 1, 2, 3, right here. Instead of 1, 1, 1, 2, 3. And then instead of 4, 2, move it down 3 spaces. So again, the general shape is the same. We are just moving them up and down and left and right. Your final answer, if these were problems for a quiz or a test, would just be the blue function. That black one, again, is just that parent function. So you should be familiar with these anchor points, the vertex where you would start, and maybe 1 or 2 other extra points.